All right, all right. It is 7 o'clock on the dot. Um, we don't have anybody in the channel yet, but that's fine. We're going to go ahead and get moving. Um, I want to show some stuff. I want to do some stuff, and then, we're going to have some fun, and I'm going to stop streaming. So, yeah, I said on Friday that I was going to do a ton of reading, and I was going to become a ROP chain master, and I was going to come in on Thursday and drop some knowledge on you and blow everybody's mind and walk out while dropping a mic. And none of that happened. I got super busy with some work stuff, some not work stuff, some things in the works that, hopefully I'll have some cool announcements soon. But for now, I'm just super, super busy outside of work. However, I did do some homework. And I said last Thursday, the whole reason that I did that I was doing Lord of the Root was because we did it at work during one of our war game scenarios, one of our war game days that we do for team building. And so one of the people that did that with us, I was talking to them, and they pointed something out to me that I did not see. So I talked about the reason we were doing this is because the aim was to be similar to the OSCP. I didn't read the next line, which is, or the second line down, the third line down. There are two methods for Privesc. And of course, this was written before DirtyCow came out, so they're not even counting DirtyCow. Meaning there is a second Privesc, and other than the buffer overflow that we had found. So I started talking to him, and he mentioned, he read a couple walkthroughs and, said that there was some pretty interesting stuff in there. So what I did is I read a couple walkthroughs. We did pretty much everything right up to the buffer overflow. I saw some interesting stuff in the walkthrough about the buffer overflow, and then I also found a pretty cool MySQL Privesc exploit as well. So what we're going to do, whoops, hold on here. Let's get that back. So what we're going to do is we're going to use the walkthrough as kind of our guide. But wait, that's totally cheating, you say. You are watching a walkthrough video, so you don't have a leg to stand on. Me, on the other hand, I do my best in boot2roots and war games to kind of go through spoiler-free and figure it out and read a bunch of stuff and, learn it and then apply it. But really, we don't learn that way in any other facet of our life, right? We have classes at schools, we have workshops that we attend for work, we go to boot camps for technology or all kinds of different stuff where people are basically explaining concepts to you, and then you apply those concepts in a lab. When I get stuck on a boot2root or a war game, I will look up a walkthrough and find the answer. Now, that doesn't mean that you find a walkthrough and then copy paste. You did it, you get all the points and everything's groovy, right? You actually want to understand what the hell you're looking at and what you're doing and why they're doing it. So I almost look at the walkthroughs as a class, so to speak, a tutorial. Say, hey, how did this guy do it? What are they doing? Why are they doing it this way? What are they trying to accomplish? And why does it work? And as we explore that, we learn something, right? So let's get our Smeagol box up. If I can remember, it's been a little while. 210, I want to say. No. Cool. Well, let's look at it here. Oh, it's not connected. Well, that's a freaking problem. Nope, that's not what I meant. Come on. Stop that. Okay, cool. I mean, that should work, right? Here it comes, hopefully. Any freaking day now. This is why I should have checked this before we started the stream. This does not seem to be getting a DHCP lease from the network. Of course, I can't do much about that as I am not root. So let's just do the time-honored tradition of restarting it. Oops, that's not restart. But while we're doing that, let's find a walkthrough that we can use. And then I have read a couple. I'm not 100% on what's going on in the walkthroughs, but we'll kind of explore that together and see if we can deduce what people are doing, why they're doing it, and see if we can replicate it without strictly copy and pasting, right? So, do I not have network connection on any of this shit? I don't. What is happening here? Why are you dumb? Don't be dumb. That's not what I meant to do again. Yeah, just click the same thing. Super good. So, okay. So I do have host only, VMnet 1. Can I just set them both to that, maybe? So I don't think we need any more. Well, we don't need internet. I can use Chrome if I want for that. So I just don't understand why that's not working. Two things, kids. Always test your demos or things are working each session, and always pray to the demo gods, because if you don't, shit like this happens. Come on. That's not going to do it. Something weird happening. Okay, let's try. We're going to do VMnet 1. And this guy's going to do VMnet 1. This is really how we should have been doing it to begin with. If you guys remember the first video, I said specifically, hey, don't put, vulnerable by design machines on a network, because holy crap, that's terrifying. Now we're just actually we're practicing that advice. So 153, 129 is so 153.29, right? That's what I said. Definitely close the window before you're done with it. 129. All right. Yes, I want to permanently add that to my keychain, because why wouldn't I want to do that? Okay, we got our shell, we got our SSH. here, I'm going to use Firefox because that's more or less clean. The only thing not clean about it is that I used it in the 2016 Holiday Hack Challenge, so it's probably got some saved bookmarks in there, but otherwise it's fine. We're going to Lord of the Root walkthrough. So the interesting thing about Lord of the Root is that the buffer overflow, there's actually multiple ways to do it. In fact, we were doing it the hard way, which I found interesting. There's an easier way to do it. It's a lot less reliable, and it's certainly not something that you would use really ever. I mean, if you're just really being hacky and you just need to exploit something, you know, for a CTF or whatever, fine. But you know, if you're doing it for an engagement, I guess it could be a okay POC code, but it's certainly not something that you're going to package and distribute or, you know, use repeatedly on a client because it's kind of unstable. So this is all the SQL map stuff we did, dump passwords. This dude does the MySQL privesc that we'll do later. This is somebody else. I believe this person also did the MySQL. Yeah. This person, if I recall correctly, yeah, we're like, oh, hey, look, we found the thing. And then it's like, oh, I don't want to do a buffer overflow. I think this guy did the same thing. Maybe this one? Yes. Okay, cool. So this guy does an interesting thing, and this is what I want to explore a little bit. So up here, he does a lot of what we did. You know, he dumps, instead of opening up in GDB and running disassemble main, he just runs obj dump, which with these flags does something similar, it seems. Here he's just figuring it out that he's got GDB FIDA, like what we installed. You know, so he loads it up, does the check sec, everything's fine. Figures out, and he skips a lot here. He's just like, oh, I figured out that 171 characters, and it's like, well, how did you figure that out? We, being super cool people, figured it out by getting our, you know, rolling up our sleeves and getting our hands dirty. He just kind of glosses over it, or she. So anyway, so they figure out that there's 170, the offset's 171 plus EIP. We knew that. He gets into PETA, runs a little, you know, quick Python script here. Probably could have done the pattern generate, but fine. So this person, like us, did a search for jump ESP. Nothing. Also looked for call ESP, which I had never heard of, but call is very similar to jump, especially for you know, quick and dirty exploit development. I tried to read up on the differences. There are a couple, but most of them were more or less over my head. And like I mentioned earlier, I haven't really had I didn't have the time to dive into this as much as I wanted. But so he does the jump and call, and then they also search for the binary representation of those. So if you remember, the ffex is actually the jump to ESP command, and this is the call to call ESP opcode. So similar to us, they looked for the jump to ESP. That was what I thought on Friday was going to be our silver bullet. It wasn't, as this person found out. And so they noticed something interesting, and this is where my lack of exploit development skills comes into play and debugging, is they're like, oh, stir copy. That's super cool. We can use stir copy to write FFE4 to memory and return to it. And this is where the ROP chaining comes into play. But they're actually going to use stir copy to find these 2 bytes and you know, write them and then use them, which is crazy talk. I mean, that seems super weird. So that's what we're going to do. We're going to try and divine. I think there's another one that explains it a little more clearly, but we're going to try and figure out what exactly this guy's doing, how it's working, and do it ourselves. So let's. I wish I could. I wish I could just like. I wish I could open this up here. Actually, let's put this on the natted network. We'll pull this. We'll pull this up. Okay. So which one? And then we'll actually just open all these up, and then they'll be there, quote unquote, offline. Kuhrect, I believe these are the ones that wrote, so that it should be an interesting one to read as well. Just get these into Kali. Like, we don't need to browse the site or anything, so we'll just get these into Kali, and then we can reference them while having Kali full screen, so you can actually see what's going on. So a couple stream notifications while I get this up. You might notice that there's no background music tonight. Even though I did the best I could to try and find music that was not copyrighted and what I thought I had rights to, rebroadcast with attribution and non-commercial and all that stuff. There were a couple copyright claims on the YouTube videos, so I've contested them because I'm fairly sure that the Creative Commons license that these songs were published under allows me to use them in this way. But I'm not going to have them in the background until those the appeals go through and I know for sure. Because the last thing I want to do is be misusing somebody's content, especially the content as good as the Symphony of Science. So it's not in the background. I still highly recommend that you guys go check it out. But there's that. Also, I was watching some of the videos the other day, and they're a little fuzzy, and that's because I'm running 1080p. I'm broadcasting in 720p, and when you have it up on a 1080p or a bigger monitor, it looks a little bit weird, and I apologize for that. But I can only stream to Twitch for some reason, and they don't resample it for me or transcode it for me unless you're a partner. If you're a partner, they'll do that on the fly for you. YouTube does let you do that, but for some reason, when I try and stream to YouTube, I get like 40% frame rate loss, and it's super jerky. And when I'm typing and clicking around real fast, it just makes it really hard to follow. And so I'm not doing that. And that takes care of that BS. We can get back to this. So let's get back on the correct network. Settings. Oh, we probably lost our... Oh, got it back. Huzzah! There's all our DirtyCow stuff we were doing last week. So also tonight we'll be doing DirtyCow. Somebody suggested what they said was a pretty stable version of DirtyCow that they've used to great effect on other things, and so we'll use that in a little bit later. But these are all, we tried some of these and they were just crashing the box all over the place. So let's get back down to, yeah, here we are. Okay. So we're going to take a look at this stuff that he's finding right in here. So we'll GDB the file. This is a copied version of the file. If you guys remember, Lord of the Root kind of does a shell game with the files on us. So we copied a version of the file to our home directory that we can play with. And if I remember correctly, maybe I should have kept a window open for us to search for GD or PETA syntax. But if SLR, if I remember correctly, okay, we can just do ASLR on. The reason we're doing this is because the files that we're using, or the files that we're doing it against, testing against, have ASLR on. We could develop our exploit against it being off, but why? The entire point of this exercise, the reason it's taken us so long is because ASLR is on, and we've been trying to develop an exploit in spite of that. That's not memory location sensitive. So we've got that on. So this guy does a couple things. So this VM map I'm curious about. Virtual memory map, I assume, is what he's saying. So this is a little different, and I wonder if this is because we're using a different file. But we see read execute and read write and read, and he actually only sees 2 entries: read execute, read write execute. Weird. Let's see if not quite quit. Thank you. Yeah. Okay, so this is the one we need. So GDB file, VM map. Yeah, this is different too. Weird. Maybe they did it on a later version. If so this is 1.01, and there was a 1.0. I'm not sure what was changed. Maybe that's what's changed. Can we do? Let's get out of this. Let's get back to our. Let's get back to our file so that we know the vulnerabilities there. We'll do ASLR on. And can we do help VM map? Yes. Okay, so yeah. Virtual mapping addresses of sections and debug process. Okay. So he's saying that stir copy is at this memory address. It's going to be different for us probably. So we're going to put a break main, and we're going to run. We'll disess main. So stir copy is actually at that exact memory address. Does that change every time? So stir copy is at the same every time. Use that address because it contains a space. We'll just stir copy +6, which jumps into the resolver to resolve stir copy. Contains a space. What? Oh. So if we just, so if we look here, they're examining 4 bytes here. So if we do the same thing, what is it? I integer, I guess? 8048320. So we see a similar thing here where what is the oh, is it because this has space in it, like spaces? D-word PTR, like D-word space PTR space. I guess I'm confused as to what this means. Which jumps to the resolver to resolve stir copy. Pop to ret to balance the stack. This is okay. So we need a pop to ret. And we can do this ROP gadget. I think we used this the other night, and I didn't know what the hell was going on. Okay, so here's the pop to ret that he's talking about. And we'll look some of this stuff up. So we're not going to just, like I said, we're not going to copy and paste because that's silly. It was the addresses of bytes. Those putting the ROP chain together. So here he used a thing He used an ASM search, which we don't necessarily need, but he did this find binary. So he's saying we need to find addresses of FF and E4. And if you recall, FFE4 is the opcode for jump to ESP. So let's see if this find FF binary. Not found. So see, this isn't, I wish she had a slightly better write-up. Let's see if this guy knows. Notice the crash, generate our shellcode, cool. ASLR to circumvent, need to modify our exploit code. Okay, so this guy actually does it, and if this is, I think this is the guy who wrote it. We can double check that. Yeah, Kuhrect. Okay, so Kuhrect, the guy who wrote it, actually does it this other way. So the way he does it, and this is the thing that I never really considered, but the way he does it is he actually does a brute force method. So he does everything that we did, and then instead of trying to reliably jump to our exploit code every time directly, he relies on brute forcing. So he notices running it several times that the memory address always started with BF, and then the last 6 bytes were different. So they, let's get this bigger. Oh, that's not going to open because we're not online in this box. So they, here's the shellcode. So what they end up doing is they pick a giant, they use a giant NOP sled. So a NOP sled or a no-op sled. What that is it's a mechanism used in exploitation. You can't always jump directly to your code. Several reasons for that. Maybe your code does not overwrite at a register like boundary, right? It doesn't, like in ours, if you remember, ours like overwrites a couple registers and it like starts at ESP and then just goes for all of ESP. Sometimes that doesn't happen. Sometimes there's a bit of stuff in ESP or in that register, and then your shellcode comes up later. Sometimes you can't reliably predict, much like this time, you can't reliably predict where you're going to land in that register. Sometimes it's a little, either because of ASLR or because of some function of the program, you'll jump to a random point, or less random, but a seemingly random point in that register. And so you use a NOP sled to deal with that. There's also some other uses for NOP sleds, but you know, that's something that we can all research on our own time. So what they do is they pick a random point, or a middle point, to say, okay, we're going to start in the middle of this random place where we could be, somewhere in the BF range, and we're going to put a giant NOP sled so that if you hit anywhere in this range of things, you're going to hit a NOP sled and you're just going to slide down it until you hit my shellcode. X90 is the opcode for no op, and literally all I don't know why I keep doing that. That's not going to help us. Literally all it does is nothing. It's a no op. It's like, okay, read the next byte. Like, don't pay attention to me at all. So if you look, oh, this whole no having net thing sucks. So if you look, they have a while statement here that's basically, while this is happening, do these things. Oops. You want to, they're actually files. Oh, they actually don't even care which file it is, right? They're not, they try this against all 3 files every time that it goes through. So then it basically runs the file and puts the exploit together. The exploit, if we look here, is 171 A's. So that's where the input buffer is. Then it runs this, which is the 4 bytes that overwrite EIP. And then 20,480 20,480 no ops. So it'll just slide right down that right down that NOP sled, and then run its shellcode. And its shellcode, I believe, does he say up here? Yeah, his shellcode is just shellcode that's generated by PETA, and all it is an exec shellcode, which just runs commands as that user. So, and then this, if you look, we didn't get into endianness the last couple ones, but Intel architecture operates on something called little endianness. And what that means is, practically what that means is when you're writing bytes, when you're writing byte addresses, memory addresses, you have to write them backwards, and that's byte backwards. So this reads actually BFCC0E11. It does, so each byte is, the byte order itself is flipped, not the entire string. So it wouldn't be 11 E0CCFB. That's not the way it's written. It's the byte, each byte gets flipped. So as they said in the write-up, they said that they noticed that everything started with BF. They chose CC because it was basically in the middle of the random sampling. And then he picked, just a couple random things here, I think. Does he say why he picked that? The last 4 digits he used was arbitrary because it didn't really matter. So he made the giant NOP sled, and he created code to find the smallest buffer overflow size to run just in case the files switch. Okay, yeah, so he's just saying that like he wrote in the loop that he'd try all of them. Get size. Wait, are they different sizes? I guess we didn't really look at these files too closely, did we? Let's create another one. 153, 129? Nope. No, of course it can't happen. Oh, yeah, that was totally right. Huh. Oh yeah, one smaller. So if we just go straight into door 3, I mean, it's got to be this one because one of these is not like the other. But yeah, look at that. I'm just pointing it at my screen. You guys can't see that. But yeah, okay. So the smallest one. So he's doing it super smart, or they are doing it super smart. They actually, rather than trying to run the exploit against all 3, they actually determine which one's the smallest and say, okay, that's the one I want to run it against. Cool. So let's see. Is there anything in this we don't understand? Because this is important, right? This is the one that we probably could have done brute force wise the first night. The shellcode that generated from PETA. These are the 3 files that it could be. Here is where they build the actual exploit payload, or not the payload, the actual exploit itself. So again, here is the standard, the size of the buffer. Here are the bytes that are being overwriting the EIP. This is the memory address that it's going to jump to, that it's going to execute. And then here's the NOP sled plus the shellcode, and the shellcode again they got from PETA. So and then here we got a while true, and then we say, okay, file size is a list, and then fn of files, they append to file size path file size of f. Okay, so that's the file size, and then index is going to be file size dot index of the smallest file size. Oh, because it's going in order of files, right? So it's going to know what the file size for door 1, door 2, door 3, and then it appends them in that order, and then it finds the index in file size of the smallest size, and then it uses that index of the files list to run the command, whichever file it is, and then append the exploit string to it. Okay, so we know how that works, right? I think we have a pretty good understanding of how that works. So let's recreate that. So we're just gonna here, we're gonna make our own Python. We have Python, right? Okay, so we're gonna make our own Python script. So this is something that you do a lot in the PWK class. You will be writing in the class and possibly in the test. It would make sense if it's the class it's in the test, but I can neither confirm nor deny. You'll be writing a lot of Python scripts that are just basically hack together exploits. Whether you're writing the buffer overflow yourself or you're modifying somebody else's Python script that has the exploit in the payload already, and you're replacing the payload with something else, you're going to be doing that. So we'll say exploit.py. We're going to be good Python people and set which Python we're using. Then we are doing, so they created this files thing, and the reason they did that is because, if we recall, they're going to use this list to find the smallest one, which is the one that has the vulnerability. So door 1 file, secret door 2 file, and then secret door 3 file. And so some of you may be asking yourselves at this point, why we're typing this, why aren't we copying it? If we're just recreating what they already had, are we just copying? And the reason that we're writing it ourselves from memory, as opposed to just copy and pasting, is because we want to make sure that we go through the process ourselves and understand what actually we're doing. So they had this, they started building the exploit, right? So they have, what are we going to do next? They started building the shellcode, if I remember. So they've got a thing called shellcode. which are all going to be this \x and then byte \x byte. That's just the way things are done. So if P to help, there was a shellcode. So if we do shellcode, if I remember, it's x86 Linux exec, maybe? Generate. Cool. And it even, actually, that's kind of neat. It even gives us this, even gives it to us in this format. So that's cool. So the exploit itself is, so it's like A times 170, right? So let's check this. So we need to gen pattern, or is it just called pattern maybe? Pattern create. Let's call it 650. Wait, is that? Oh, there's a way to make it an argument. Pattern arg. So pattern arg 650. There we go. So then we run it. Okay, and it seg faults. And if I remember, let's see here. And registers in memory. Does it say it here? It even has something built in to generate a not sled. I thought there was a... Oh, okay, yeah. So you just do pattern search and then the register. So yeah, so it's 71. And then we were going to find... So what they were saying is that the ESP was always BF something, right? So if we just run, it'll happen again. So BFFF. Oh, we don't have ASL on. So run BFA5, run it again. BFE6, AF, E0, A0, A1, DB, 87. Okay, so it's always BF, and then it's something crazy. And so they picked CC because it's in the middle, right? So the way I did it a lot when I was doing the PWK is I like to separate out everything, right? So what I would do is like buffer equals, let's not call it buffer, but you know, B overflow equals, and then we'll do like A times 171. And then, so this would become like B overflow, right? And then we'll have EIP equals. And then so what they did, perhaps rightly, perhaps not, is they kind of picked something in the middle. So if we recall, EIP, if we recall, it's OX, BF, and then CC, and then like 1A, 2B, sure, right? So we have to flip those bytes. So it's going to be 2B, X, 1A, backslash X, CC, backslash X, BF. So that's our EIP. And then we'll put that there. And then the next thing they did is did a ridiculous NOP. So they'd have like NOP sled equals, and then it was 90, not 90, but 90. And then times, it's like 20,840 or something like that. So we'll put our NOP sled there. And then we'll plus our shellcode. Cool. So that is the exploit. That is how, this right here is what will overwrite the buffer, or overflow the buffer, overwrite the EIP register, and then put the payload, this is collectively basically the payload, into the ESP register where we can get it. So let's, so then they had a while statement, right? And they did some wizardry with the OS command. So this is where I need to look back because I'm a terrible Python programmer. So they did some stuff. Oh, he imported OS and sys. And then so file size.append OS path, file size.index. So while true. So while true, if you're not aware, basically just means run forever. True is like always. Yeah, true equals 1 as an integer, and or true is anything greater than 0, and false is 0. That just happens forever. While true works forever until you break out of it somewhere in the loop. But we won't break out of it. It'll get hung up on something. So then we set something called file size, which is just an empty list, right? Oops. So, and then for F in files, and what this is doing, for commands, if you're not aware or how they work, is you've got this iterator or this stand-in, and then in files, which we have up here, right? So what happens is this guy, when this gets ran, it's going to say, okay, who's the first one in files? This is the first one in files. So now inside of this loop, you can essentially assume that F equals this. And then the loop finishes, and then it's like, okay, what's the next one in files? This is the next one in files. So for that loop block, F equals that. And then so on until it's done iterating through, and then it exits out of the for loop completely. So in this, we're going to do, it's like file size dot append. And then it's going to be the size of os.path.getSize. So os.path.getSize F. Cool. So we're going to, up here, we're going to import OS and sys, right? So what this is doing is saying, hey, Python, I need you to import the OS library and the sys library. This can be written similarly like this. If you want, the comma, next one is just a shortcut. But what that does is it gives us access to these other functions that are part of those libraries. So inside the OS library, there's this path that has a, is that a class, path class? I'm not a Python programmer, but I think it's a class or method maybe. And then it's got this get size function, which will take a thing, a path, an OS path, which this is, and then get the size of it. So we are appending that to our file size list. So then we get, the next thing we do is we go through, we find the smallest file and we exploit that file. So in order to find the smallest file is we set something called index. And then we set index equal to file size, since it's a list, has a method called index. And what that does is it takes a value. It takes a thing inside of it. And then it returns the index of that. So since we count from 0, this is the index 0 of files, index 1 of files, index 2 of files. All it's doing is finding the index of min is another function that basically takes the smallest value. So it's finding the index of the smallest value in file size. So I already forgot what that looked like. So we do index equals, and then it's file.size .index. Can you do that? That feels wrong. I wouldn't ever do this. That it just gets messy. So we'll call this I don't know what else to call it. We'll call it size index maybe, just to not get confused between these two. This isn't a very large program, but if you have a big program, you don't want to start like calling the things same name as other things. And this is going to be min of the file size. So now size index is literally just the, all this is an integer that's pointing to the index of the smallest file. So then we actually run the command, right? So we do os.system. So os.system, and then we're going to run files, and then index is going to be size index. So what this is saying is that OS system is a way to run stuff from the operating system. And it's going to take whichever one of these has the smallest file, is what it's saying. And then plus, and then just add a space in there, and then we're going to use our exploit as the input. So let's see if this works. This is going to run a lot, right? Since we're not flipping back and forth, let's. Maybe it'll never work. Bah ha ha. We'll sit here till the end of time. Oh, what is this? What is this? What is this? So let's do something that only root can do. Oh my God, it worked. So what is our, okay, so if we cd root, there is a flag.txt, cat, let's cat it. And there is the flag. So again, it wasn't very elegant, right? It basically crashed the system, or the application over and over and over and over and over again. And the only reason that this worked for us is because we were doing this against a set UID application. If we were doing this against a running service, the service is not going to come back up like this, or at least not that quickly, right? We're gonna knock over a service. We're going to alert the administrators that something's going on, and at the absolute best case for us as the attacker, we're going to force it to relaunch over and over again, which is going to take several seconds at minimum, right? A lot of services can take upwards of 30 seconds to a minute to fully refresh from a crash like this. So only works for this specific use case. It's not really the optimal way to do it. So I mean, that's cool. We finished. We got the flag, but again, hello, Kuhrect. That I'm not sure how to actually pronounce your username, but hello and welcome. But so yeah, we technically won, which is the best kind of winning, but really we want to find a better way to do it than this. So let's get back to our more elegant way of doing it, the more reliable way of doing it, and the one that will fire off first time every time. Because that's really what we want, especially if you're exploiting services, that's what you want. So let's exit out of this, and we can. Oh no. All right. So pkill, for those of you who do not know, is process kill, and it lets you just put a name in there, and it'll just kill that process. Or all processes that match that. So be very careful with it. But I happen to know that. Actually, I don't happen to know. Anything that Smeagol can kill running Python is the exploit. So let's go back to this other thing and kind of see if we can figure out what's going on here. This struct packed, if I recall correctly, is, just what is struct pack doing? Let's find out. Struct pack. Strings is packed binary, so that's cool. So struct pack, return the string values packed according to it. Oh, okay. So yeah, it's like what Kuhrect says is to convert address to little endian. So yeah, so what this is doing is that must be the syntax that's going on here, is saying, hey, make it little endian. Cool, because endianness sucks. It was a pain in the ass to deal with. So what this is saying is, so if we go back into GDB, let's figure this out. So what they're doing is they're looking for FF and E4 inside of the application. So, oh. Okay, let's find out what this means, because maybe that's the part that I'm not understanding. So pop2root. Oh, a raw primer. Now maybe that's what I need to freaking do. Yeah, the write up definitely skips a lot, and that's kind of where I'm having some issues. But so he's looking for pop2root, but I'm not really sure why. So that's kind of what I want to see if I can figure out. Pop3root. I don't. Pop return. What does pop? What's the pop instruction? Is it like? Is that like Perl? To pop to the last return address, or pop the last return address off the stack. Okay. So pop takes the top value of the stack and assigns it to a specified variable. Stack size will decrease by 1. Okay. I kind of get it. Yeah, so yeah, I knew it was assembly, but I was just making sure that pop, like the pop instruction, worked as similar to Perl, which it seems to do. It just takes one off of something, in this case the stack, and adds it to, puts it in a variable. Let's check out this wiki page that Kuhrect linked us. Explain the need for pop. ESP, EIP, got it. The sequence of instructions. Important for the exploits to succeed. Only the fact that ESP is moved towards higher addresses twice, and then a return is executed. Oh. So we're not actually popping a return address. We're popping whatever, and then return. Okay. So pop register occurs, ESP is moved towards higher addresses by 1 position. 1 position is 4 bytes. Yep. Each time a ret occurs, a return occurs. The contents are put in the EIP and executed. Wait, each time a ret occurs, the contents of an address put in EIP. In order to create ch, the address of pop-pop-ret sequence has to be found. Enable the attackers to move ESP towards higher address spaces twice and then transfer execution. Need to explain why we need to move. Okay, yes, perfect. That's the question that I had in my head. Why does it need to be moved to higher addresses twice? Explain in detail how structured exception works. Records. I almost get it. So the fact that the attacker can alter a portion of the stack by buffer overflow is there can using shellcode in the stack in order to alter the the previous technique will succeed to overcome safety. Oh, okay, so that's similar to what we were talking about before. Fixed by jump to shellcode. Okay. Similar. System tries to handle the exception that is raised. Sets up the exception. Establish first record. First handler record contains the address of the next SEH record. All right, the SEH handler. Versus the exploit. So an exception is yeah, I don't think it is. And in fact, so as I'm kind of reading through this, I wonder if this person just kind of blindly followed that, right? Let's get back into this. do we really need a boot2root, or do we just need um, we need a boot2root to balance the stack? See, that I don't understand. That's the thing that is like throwing me off right now. So 50E. It's easily located with GDBs. Rob Gadget. Yeah, we know that. It's the address of FFE4. Provided those. How did it provide those? I wasn't able to find it. Can we just use searchman maybe? .4852C. Provided those. I don't understand how they provided those. Let's look for something. No, no, it's not. Oop, I didn't want that. Go back. I don't want to find strings. Oh, good course on binary exploitation. That will be super helpful because I need that. The next, oh, that looks cool. I plan on, so soon I'm going to be doing the SLAE and GDB courses from SecurityTube just to kind of get my head around assembly and debugging, because that's something that I'm pretty weak on. And then I was planning on doing the OSCE to continue my OSCP. But this is all of this binary exploitation. So I'm much better with like network stuff, web app stuff. This actual exploitation, like actual Debugging, finding exploits, I'm not very good with. So ASM search I knew. And this is just going to dump all the gadgets. Not found. What? Oh, there's no... I'm an idiot. Is that why I couldn't find anything earlier? Because I'm awesome. Yeah, that's... How was I looking... Wait. Oh no, I was running. Okay, so... Do I need to be in the... There we go. Okay, so you need to be in the program. You need to actually be running in the program for this stuff to work. All this shit's getting crazy. Okay. So that's a cool command. I don't want to create exploit patterns. That we've already done. So if we do, what was the thing we did earlier? Not running it. Search mem, oxff. Search mem, oxff. Yeah, thanks, Kuhrect. I really appreciate the insight that you gave, and hope to see you around. So what are they? So are we just grabbing? Oh, are we seriously just grabbing like the last byte of each of these? So, you know, the jump from... So like the jump from this byte. So if we do like... Let's grab something in file. So if we examine like for I this. Oop. Oop. Okay. So when do I normally stream? So far it's been Thursdays. I just started this stream, like security streaming last Thursday. So far, it's been Thursdays. I don't know if I want to stick with Thursdays because I generally have engagements on Thursday nights, or like pre-existing stuff I do. If I begin to do this regularly, I don't know, maybe I'll keep doing Thursdays. Thursday seems to be good. I'm on the Pacific coast, so I use the Pacific time zone, and it's always at 1900 because I need time to get home from work and get some food and kind of situate myself. So 1900, and then just kind of whenever I find time. So far, Thursdays. So I think the next thing that I'm going to be streaming is some over-the-wire stuff. I'm going to do some early Linux, like easy Linux stuff, and kind of progress more into some advanced Linux stuff, and then maybe do some web app with Matilda. I think is kind of the next path of things I'm going to do. So 2, 3, 4, 5, 6, 7, 8. Yeah, thanks again, Kuhrect. So what if we just do 1? So right there, okay, so this guy is an F, right? So if we look at what this guy was saying, so we need an F and an E4, and the way he puts them together, so if we do the search mem E4, we can just grab this, yeah? So we do X1 binary. That's just E4. So we are not starting soon. We have already started. So here's our F, and here's our E4, yeah? Is this going to work the way we expect it to? So this is where he's building the exploit like we did earlier. So he's like, start with a blank string and then add equals the buffer, or the the original buffer, and then he writes, I'm not actually sure. So strcpy dest source. So use strcpy +6. Oh. Wait. Do I understand what's happening here? Let me, gadget. Not rot gadget. Maybe I don't. Maybe I don't understand. So the address will contain a space. This is up argv. Second address is pop to ret. I don't understand what's happening here. So okay, so again, this is just reorging things as little endian. Fine, that's good. Def right what where? So he sets up his buffer, and then this is supposed to write FF, the address of FF, and then the address of E4, which combined makes jump ESP, which we've discussed. And he's writing the addresses of those two things into the EIP, or he's using this somehow to write the addresses of these two things, to write these two things into EIP. And then he grabs this for some fucking reason. What the hell is this? For fucking nothing. I mean, what? No, that's the wrong thing. Sorry. What the hell is this? Why would he hard code that? I mean, does this work? Can't imagine this works. Let's try it. Or, I mean, obviously it works. He wouldn't have written a thing about it. I just don't understand. I don't understand it, is what I am trying to say. Oh, I see. He writes it as a so. So I mean, we could actually adapt this to have our other to have the code in our other thing. So if we our other exploit, we could actually like bring in this while true loop, or not the while true loop, but this part of it to make it like auto work. So let's do that. Ooh. Tab sizes are weird, VI. So we're going to not just import struct, but we're also going to import the OS and sys. And remember, this could all be written as import struct OS sys, which we'll do. If you don't know basic VI shortcuts, you should learn them. I am not a VI wizard by any means, but man, being able to navigate in VI is pretty handy. And if you're like one of the 4 Emacs users out there, I respect your decisions, but I don't agree with them. That's not true. I don't know Emacs well enough talk trash on it. VI is just what I know. So, anyways, so we need to set up our files, right? So let's files equal, and then we got secret door1 file, and file to file, or nope, not door2. Stupid wine. You are getting in my head. All right. It's not going to be exploit. It's going to be Z, because that's what this dude used. This person, could be a she. I'm from California, so everybody's a dude. It's funny to see two girls talking to each other and call each other dudes. I mean, it's not funny because it's normal here, but that kind of shit actually happens. It's not just in the movies. So let's see. We got everything? We're ready to go? This should work? Yeah? Files, file size, good? Yes? Cool. Let's see if this works. What the fuck happened here? Nothing happened here. So something broke. Still not 100% sure this works. Ben, maybe the shellcode sucks. Let's grab the shellcode from our other one, which was, if you recall, generated by PETA. So we can even do it again, right? Shellcode generate. Is it generate? x86 Linux exec. Cool. So you could, do a shortcut here instead of having to write Python exploit every time. Let's chmod plus x exploit 2. Boom. Import files syntax. You can't do that, by the way, unless you declare what the fuck you're using up here, or what interpreter should be running this, right? So, so this is how I learned to do it, userbin env, when I switched from Perl to Python, and of course Perl was userbin Perl. I recently read that this is just like some hacky bullshit that we really shouldn't be using, and we should be explicitly saying which Python interpreter we should be using. But that's the way I learned it, so deal with it. Also, I use userbin env Python 2 instead of just Python because, I also code in Python 3, and I like to be explicit about the version I'm using. So, see, there's some weird stuff happening here. I don't know, man. I wanted to make sure it worked before I thought too much about this. It's obvious that it should work, right? They've done it. It's here. They did it. But I don't know. Seems weird to me. See if this guy did it. Okay, smashing the stack, generating a shellcode. Great. So this finds the correct binary. Cool. Sort files. Oh, so this is a different way of doing it. So he grabs the path or he creates the path, secret. He says all files in this path, all files under secret, and then he sorts them by the key of get size. So instead of what we were doing, where we kind of did this for loop of like, okay, let's create a separate list, and then we'll put all the sizes in that list, and then we'll compare, use that to compare against this list. This is a lot. This guy seems to actually be a Python coder. This is the shit that the guys at the office write, as opposed to me. I write stupid shit like this. They write stuff like this. So here's your EIP offset, the target address. Oh, this guy's doing the same thing. Yeah, this guy's doing the same thing. He's just, actually literally the same thing. He must have read that guy's, the Kuhrect write-up, because like this exploit code is identical. I bet you it's even the same shellcode as the Kuhrect write-up. I can't actually open this, but if we 31CO50, oh yeah, it's even the same shellcode. Does ours generate the same way? Oh, it does. Okay, so it's not that weird, but he's using the same, like literally the same EIP offset, the same not padding. And he puts together the exploit like we do. Though it seems weird that they do it this way, right? It's like, oh, well, we want to, like, why not just put this there? And then this, like, I don't know. It seems weird. Seems a weird way to do it. Does this guy have a different way of exploiting the buffer overflow? Maybe a better way of writing it? Maybe this will be my gift to the world. Maybe I'll learn all this stuff years from now. And I'll do a write-up that actually explains what the hell's going on. Because, oh, this guy's just doing the, what did he do? SSH. Oh, he just used this is a kernel exploit. It's not going to work here. Yeah, it's just like a Linux kernel exploit that he used. So he did that. We're gonna do DirtyCow, I think. Somebody posted a link to a easy to use DirtyCow, or at least a reliable DirtyCow exploit. So we're gonna go ahead and do that since we totally failed at it last week. Let's switch this over to the internet real quick so we can download it. At the very least, we're gonna see if it works. Oop. So we're gonna head cow.c, cowroot.c, and if you see they have compiling instructions. It also wants us to uncomment the correct payload first. So let's take a look at that. So this is something that you'll see again as you're working through your PWK. The course, obviously, offensive security maintains the exploit DB, and so they reference exploit DB quite a bit. The PWK doesn't. It teaches you some basic buffer overflow, but it's a lot of using other people's exploits, but finding other people's exploits, modifying them to your purpose, maybe correcting them a little bit, and then deploying them manually. And so so what you will find as you're going through all those exercises is that a lot of good exploits, at least, have some information commented up top. They'll have compilation suggestions. They'll have use examples. They'll have maybe some instructions, like they'll come with multiple payloads. In the PWK, you generate your own payloads a lot, and it walks you through how to do that and how to select payloads. But matter of fact, here you can see that it's got MSF Venom is what it's using to do an x64. If I recall correctly, this is going to be 32-bit, so we'll use this one instead. So what we will do is so we're going to uncomment this one. Are they commented the same? Oh, I see how this works. Okay, so they comment the whole thing, right? No, they don't. Oh. 64-bit is, so this is a multi-line comment, start, end, and so it's just commenting this. We will get rid of that, and then, yeah, and then we'll kind of there. So actually, we don't even have to do this. There. So this is commented all the way down to here, and then we can get rid of this end of comment string. So this should work, and then we'll take this. Whoop! What happened here? What did happen here? This is something we should get straight to the Lord of the Root box. Warning. Warnings don't concern me. Note. So it worked. Did we actually have it? We do have an output. Okay, so let's put ourselves back on the host only and SCP it over. All right, so okay, so we'll SCP cow root to Smeagol at 192.168.153.129, if I recall correctly. We're 128, so that would make sense. And we'll just do that to home Smeagol. That's going to take like forever. Wait, what? Oh, yeah, I'm an idiot. So now we actually have to SSH over there. I was like, why does this look like a Kali prompt again? the wine's starting to get to my typing capabilities. Okay, so let's see if Kuhrect works. Let's do it. Kuhrect. Kuhrect, go. No! Exec format error. Is that because it was built on a 64-bit machine? Probably, maybe. That seems like something that could be wrong. So let's so we will SCP. We're gonna do the Kuhrect.c this time. Same shit. Smeagol at 192.168.153.129. Home Smeagol. So again, we'll head Kuhrect. Let's actually rm Kuhrect. So we'll head Kuhrect, and we'll use its suggested build. Once again, we got a bunch of warnings. Maybe they matter, maybe they don't. Oh my god. Oh my god. It's a real thing that happened. So now we're root with GID Smeagol groups root. If we go to /root, here we are in /root, we can cat the flag. That's the flag. And so this was the second way we did it. So yeah. So if we can actually cat, and it became unstable. So it's not even stable. It does work, but it becomes unstable. Don't forget to restore temp back. Oh, maybe that must be where it wrote etc password too. And actually, yeah, that could be super bad. So at this point, this machine is probably completely effed, given that etc password has been overwritten. And just do a quick reboot to see if we can get it back, but this might be the end of the stream for the night. As promised, we did do the buffer overflow. It wasn't because I came back as a ROP god. We did look at some walkthroughs, but hey, that's how you learn. You see how other people do. You read some tutorials, you read some lessons, and you kind of move on. So let's see if it lets us in. I'll be damned. So I guess it doesn't need etc password. Oh wow, etc password's back. That's kind of cool. Interesting. Okay, so neat. Anyways, that's going to be the end of the stream for tonight. I hope you guys learned a little bit. I know I did, and someday, somewhere, I will learn ROP chaining and be able to explain it to all of you like I should be able to do. If you look in the, I'm going to repost it, Kuhrect earlier, let's actually get his name in there too, just so he gets credit. Kuhrect posted this GitHub link to a modern binary exploitation class, which seems super interesting and definitely on topic for what we've been talking about the last couple of days. I will definitely be taking a look at it as I move through the SLAE and the security tube GDB class in my preparation for the OSCE, the cracking the perimeter class and the OSCE. So I recommend you do as well. And again, thanks everybody for joining me. I will get this video up on YouTube. I'm not sure how I'll slice and dice it, but it will be up there probably tomorrow morning. So thanks, guys. If you have any questions, comments, concerns, Twitter's the best way to get a hold of me. It is all in the additional web presence in the description down below the video where you're watching. And I look forward to interacting with you guys or seeing you guys in future streams. Have a good night.